This pencast covers compound interest versus continuous interest. My name is Lisa Cohen. We'll start off with compound interest, and the formula for compound interest is A equals P times 1 plus R over N, all raised to the N times T. A is the future amount, P is the initial amount, R is the interest rate, N is the number of compoundings per year, and T is the time in years. We'll start off with an example showing us how various lengths of time will change the amount of money that we'll have. So consider an original investment of $100,000. The rate 6.5%, which we use 0.065. We always use a decimal. It's going to be compounded twice a year. And we're going to try this for various values. So imagine we want to know how much interest we'd have after no time. And this should work out to be our original amount. So we plug it into the formula. Now we use order of ops, and we know that anything raised to a 0 power equals 1. Therefore, we get 100,000, which is our initial investment. No compounding, no interest has been added yet because no time has gone by. But now we'll do the same thing for 4 years. Plug the numbers in. 1 plus 0.065 over 2 to the 2 times 4. And if you plug this into a calculator, you'll see that you end up with $129,000. The exact answer is $129,157.75. And that's only after 4 years, assuming a 6.5% interest rate. So we can adjust the number of compoundings as well. It depends upon the problem. So you see, we can decide on the time, we can decide on the interest rate. And we'll do this again just to show you how compound interest works. It grows exponentially. And keep in mind here, it's only being applied twice a year. It could be applied monthly. And that, of course, would increase the amount of money. If you put this into a calculator, you get as an answer $166,817.25. Now, when the number of compoundings per year becomes so often that it becomes continuous, we call it continuous compounding. Now the formula for this is A equals P E raised to the RT, where E is natural base E. The other variables actually are exactly the same as in the other formula, but notice we don't have it being compounded monthly or twice a year. It's all the time. And it makes a difference in the amount of money that you'll have in the end. For example, consider you start off with $2,000 and you want to have an interest rate of 6%. N equals 2. Interest is being applied twice a year. I'll call this part A. And we want to know how much money we'll have after 5 years. Then the answer would be 2,000 times 1 plus 0.06 over 2 raised to the 2 times 5. And if you work this out, you'll get approximately $2,687.83. Now, if we assume the same thing except that it's being compounded continuously, so there is no n in this problem, if we plug this into A equals P e to the RT, we get $2,699.72. Now that may not seem like a huge difference, but this is only after 5 years. We're only starting off with $2,000, and so it doesn't make a huge difference. But if we take T out to 30, and if we started off with a principal amount of $10,000 or more, it would make a massive difference. So the difference is how often the interest is applied. So continuous means it's being applied all the time. Compound interest, it'll tell you the number of times the interest is being applied per year.